Hi, this is intensive revision for chemical bonding. Basically, there's only two kinds of bonding that we are interested in, ionic and covalent. So under ionic bond, there are three basic properties, namely they have a high boiling point and melting point. And of course, I keep asking you the reason why, but in the following slides, I'll be able to explain to you. Secondly, they can conduct electricity only in two states. We have them in aqueous and molten state, and they are all very soluble in water. Everything that's true for ionic will be the entirely opposite for covalent. As I said, always remember one side, the other side is the opposite. Okay, so coming up, I said just now they have high boiling point, melting point. Why? You can see over here that they are bonded together by strong electrostatic force.
Sodium and chlorine are examples of atoms that combine ionically. Sodium is a reactive, soft, silvery metal of low density. Its atoms have one valence electron. Chlorine is a corrosive, yellowish-green gas. Its atoms have 7 valence electrons. When mixed, the two atoms combine explosively as an electron moves from each sodium to each chlorine atom. A closer look at the resulting product reveals the formation of small white sodium chloride particles, also known as table salt. Water is an example of a compound containing two oxygen-hydrogen covalent bonds.
Hydrogen and oxygen
is a
both are
colorless,
non-metals, so they are
explosively
covalent
reactive
bonds.
gas.
Now this
Its atoms have one valence
show a
electron.
comparison of ionic and
Oxygen
covalent
is a
bonds.
colorless, reactive
I
gas.
hope I didn't confuse
Its
you
atoms
guys
have
that are
6
reading
valence electrons. When the two gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and two hydrogen atoms. A closer inspection of the inside of the container shows.
So, coming up. So why do they have high boiling point, melting point? Because they are connected together by strong electrostatic force. So a lot of energy is required to break the bonds. Okay. Coming up, they can conduct electricity, but only in molten and aqueous state. So why is that so? Okay, because in these two states, the ions are free to move. All right. So coming up, this is an extremely interesting video that I found. They actually do a comparison between ionic compound and covalent compound. So if you take some time to read through this video, you actually get some inspiration.
So I think when I did the demo with sodium and water, it showed that the hydroxide is produced because the solution turned basic, and the hydrogen was produced because it exploded into flames.
Sodium plus water give you hydrogen gas and sodium hydroxide.
How do you know there are ions in any solution or even in a salt? Well, we've got to demonstrate that, I think, is the best thing to do. So what I have here is just some water. I'll put that there, and more water. Then I have this awesome testing machine, which is lethal in the wrong hands.
Basically, they are trying to show that metals conduct electricity,
and there's a light bulb on the bottom, as you can
compound
see, which will be on the
solutions
top in
conduct
a minute. And there's a
electricity.
couple of electrodes sticking
This
out
is
the
an
top.
open
And if something
circuit.
connects the
You put a
electrodes,
metal on it,
the light
yes,
bulb lights,
up,
okay?
because metal
So
conduct
obviously a piece of
electricity.
metal conducts electricity very well. The electrons fly
Metal
through it, and
have
the light bulb lights up.
electrons, so they
Now,
conduct
how about water? Is
electricity.
that an electrical conductor?
Now, if I insert this open
some
circuit
people- no, it's not. This built
light
to the
bulb
tap.
into water, do you think you'll conduct electricity?
Some people say yes, some people say no.
Most of you would think that's yes, okay?
What do you think? Well, not enough to light up the light bulb. But if I was having a bath in there and somebody threw this in, I'd be dead. Okay? There is enough electrical current passing through there to zap a person, but not enough to light up a 20-watt light bulb or whatever this is. So not a whole lot of current travels through. In a light bulb like this, you might have an ampere of current to light it up nice and bright. In the bathtub, it only takes milliamps to go through your body to kill you. Okay, so
Next coming up,
distilled
he's
water,
going to
just plain tap water,
dissolve some
not much
sodium chloride.
conductivity.
Sodium
Now,
chloride,
what
when
is
they
it that
dissolve in
carries
water,
charge?
that's
In the
highly
case
soluble.
of this thing, it's electrons being transferred through the
something a
spatula,
lot.
and the electrons are mobile in the metal, so they are what carry charge. But what if we have something in solution, like some sodium chloride?
Remember,
table salt.
ionic compound consists of
Safety
metals
seal.
and non-metals. Sodium chloride, NaCl, Na is metal,
So let's put
Cl
some
is
salt in
non-metal.
here.
He throw the sodium
Stir it up a
chloride in
little bit.
water.
Now, this is
He dissolve
dissolving.
it because
And
they
my
are
claim is
soluble
that
in
this is
water.
turning into
They
ions,
become
but
ions.
the only way we could know
So
that there
how
are
do you
ions in there
prove that
would
there
be
are
to
ions? Says when you
show that the
actually
solution has some
put
electrical conductivity.
this thing here inside.
And you can see
yeah,
that,
you see,
of course, it
light
does.
up.
So, what's happening here? It's the ions now in the solution that are carrying the charge. Positive and negative charges, positive sodium ions, negative chloride ions, those are the things that are carrying the charge from one electrode to the other and completing the circuit. In ordinary water, there are not sufficient number of ions. There are some ions, but not a sufficient number to
They are ions, but
to
not
see
enough.
that
Okay.
uh,
For simplicity's
enough current
sake,
would be
you can
carried
actually think
to
in
light
that
up this
manner
thing,
if you're doing
light
for
up this
just for O
bulb.
levels.
Now, does
okay?
it mean that
Just
when we
think in the
dissolve
manner that
something,
covalent
it
bonds do not
necessarily
conduct
conducts
electricity at this point of time?
electricity?
But
Well,
when
here's
you
some
grow
sugar.
up to
So I'll
higher
throw some sugar in.
tertiary level, then you have to think in another manner. That would be faster
Stir
for
that
all
around.
of
You
you
know
that
that sugar
are
is
rushing for
fairly soluble in water. I put about the
revision
same amount of sugar in
this
there that I
chapter.
had sodium chloride in the
Now
other
they're
one.
dissolving sugar. Sugar
So
is
let's see what
C6H12O6.
happens.
Obviously
Zippo.
covalent bond.
So just
it
because
doesn't light
something
up.
dissolves in
Because
water does
covalent
not
bond
mean
compounds
that
do
it
not
has
conduct
separated
electricity.
into ions.
Okay, so just for fun's sake, okay, let's moving on. Those of you that know what I'm talking about, I think you have watched that in the class, so I'm not going to go through that. Next, coming up, we have to explain that they are mainly soluble in water. Let's take a look at this. Water, although covalent, has a separation of charges. The positive charge of the water molecules will be attracted to the negative part of the ionic compound. So let's take a look at this. And also, ions, they are highly brittle. So a little bit of pressure will cause them to be shifted. So when the ions of the same charge are brought together, they will repel each other. That is why you notice that salt is always very powdery, very brittle. But yet sugar, you will see them in a huge and bigger pieces, all right? Now, coming up, we have covalent bond. Now, they have low boiling point and melting point. Why? Because the force of attraction, which is the van der Waals force in the water molecules, are very weak. So very little energy is required to break the bond. Now, the difference between just now what you see in the ionic and covalent is this. Now, in covalent bond, when you are melting, okay, or when you are boiling, you notice that you're breaking only this thing called the intermolecular bond. In ionic bond, you're breaking the interatomic bond. Okay, so all of them are strong bond. Whether you're ionic or covalent, they have strong bond. But the difference is covalent bonding, you're breaking the weak intermolecular bond. That explains why they have very low boiling point and melting point. Because the bond between the molecule and the molecule is weak. So very little energy is required to break the bond. Moving forward, now lastly, they do not conduct electricity because they have no ions at all. Alright? And then next one, they are mostly insoluble in water. Now, very common questions that we have over here, questions 9a. Now, they say draw the structure of two substances that contain one chlorine, one named substance with ionic bond, and one named substance with covalent. Now, if it's chlorine, if chlorine want to become ionic, they have to combine with? Yes, with a metal. So choose a very simple metal like sodium. So when chlorine combine with sodium, you will answer as sodium chloride. When they say name, you have to name it out, spell out in details, alright? So next compound will be the covalent compound. So chlorine can actually combine with what? I love it when my students pick hydrogen because it shows that it's simple and it's straight to the point. Hydrogen plus chlorine give you a hydrogen chloride, or in other words, HCl, hydrochloric acid, alright? 9b, two ways in which the physical properties of these two differ. Physical property means the three things: low boiling point, low melting point, whether they can conduct electricity, and whether they are soluble in water. So you compare them, alright? And of course, you have to explain why. So, for example, let me give you an example for 9c. If in 9b, you say that ionic compound has high boiling point and high melting point, while covalent compound has low boiling point and low melting point. And in order to explain that, you have to say, because in ionic compound, they are bonded together by strong electrostatic force, so a lot of energy is required to break the bond. Whereas in covalent bond, they are conducted together, they are bonded together by weak intermolecular force. So very little energy is required to break the bond. All right. I hope this is helping you guys. Next coming up is 2009 questions. The arrangement. Of course, one is gas, one is in liquid state. The movement you can compare. Arrangement you know as well. Okay. Why molten KCl potassium chloride can conduct electricity? Because in molten state, the ions are what? They are mobile. It's ions. Don't use electrons. Electrons is only for metals, okay? C, explain why liquid hydrogen boils at a very low temperature. It's a covalent bond. So they are bonded by? Yes. Very weak intermolecular bond. Alright, so very little energy is required to break the bond. Coming up, methane. Now, I like this question very much when they say methane, because methane is under organics, it's CH4. You draw it out, and then you will see C in the center.